Okay, so in this video, we're going to talk about decreasing functions. And remember, I think this is almost more of a misnomer because in this circumstance, when a function is decreasing, a function doesn't always have to be decreasing to be considered a decreasing function. There can be portions of a function that are decreasing, and there are portions that are increasing, and there can be portions that are constant. So when you hear in this section that a function is decreasing, it does not mean that it is always decreasing. But let's go ahead and look at an example of a function that is always decreasing. So a function that is always decreasing could be a linear function. So if I were to give you the function f of x is equal to negative 3x plus 2, function negative 3x plus 2. This is a linear function, and it's in the form of y equals to mx plus b, or f of x equals to mx plus b. So y equals to mx plus b. And notice here our slope would be equal to negative 3, then our y-intercept would be 2. So we know that it would intersect the axis at positive 2 because the y-intercept is positive 2. And if a slope is equal to negative 3, that means that it is really negative 3 over positive 1 or 3 over negative 1. It does not matter which way that you write this. And by definition, slope is equal to rise over run. So we're always going to be rising negative 3 or decreasing 3 and then running 1. So we're going to have a function that looks something probably like this. It's going to look something like this, and we recognize that it starts in quadrant 2 and then it goes all the way down until quadrant 4. So examine this function where I highlighted in yellow and where I ended in yellow, we recognize this function is decreasing because he starts at the top left of the page and then goes all the way down to the bottom right of the page. So we can say that f of x is decreasing, but then we must describe the interval over the domain in which this function is decreasing. So we recognize that this guy actually starts decreasing over here at negative infinity, and then he decreases until positive infinity. So he's going to be decreasing from negative infinity until positive infinity. And we always have to describe this in an interval, so infinity and negative infinity always get a set of parentheses enclosing them. They are just describing an area. They are not portions that will ever have a bracket because they're not finite values. So let's look at a function that is slightly more complex than a linear function. So if we come down here, let's just go ahead and draw a graph. We'll just draw a graph. And we can describe a function that could be doing more than just decreasing. So let's go ahead and say this function starts from the bottom here, and then he dips back down again, and then he shoots up, becomes horizontal, and then ends up continuing on down here. So I went a little bit past our axes, but that's okay. We can just assume those axes extend out further. So I'm just going to go ahead and describe these points. I'm going to write some critical points in here. So here I'm just going to describe as negative 5. This one will be negative 4. This one will be negative 3. This will be negative 1. This will be 1. This will be 2. This will be 3. And we could say this one over here is going to be 5. So these are just random points that I picked on the domain. There was nothing logical about how I did it. But when we examine this, some of them may be more important than others. So all of them are not important. So if you want to now, go ahead and pause the video and determine where our function is decreasing. So take a set to determine when your function is decreasing. And it may help you to highlight or color in the portions where our function is decreasing. So hopefully now you did that and you came back. I'm going to go ahead and change the color so hopefully you can see it on your screen that this portion is going to be decreasing here because it's going from top left to bottom right, and then it's also going to be decreasing over here because it's going from top left to bottom right one more time. So in this circumstance, we have two different intervals where our function is decreasing. And remember, at these points right here, and I'm going to highlight these in red, this point and this point and this point, at these points, our function is neither increasing or decreasing. So at those points, your function is neither increasing nor decreasing. So we are never going to include them in our intervals. So Remember, from -4 to -1, our function is decreasing, and we will always enclose these in an open interval. They will always be enclosed in an open interval. And notice again, it starts decreasing here at 3, and then it keeps on decreasing all the way out here to positive infinity. Positive infinity meaning that it's far and far and far to the right. So we're going to say this guy increases from 3 to positive infinity. We never ever include either one of these values because, again, where I highlighted in red, the function is neither increasing nor decreasing. He is just constant, and because we have two different intervals, we have to join them using a U, which stands for union. So here we have two different intervals where our function is where our function is decreasing. So we join them by a U. Let's go ahead. Hopefully you watched the last video. How about you now pause the video and determine where this function is increasing? So how about determine where this function is increasing? So hopefully you pause the video and try this out on yourself, and you recognize that my function is increasing from -infinity until -4. Oops, let's change that color there. I'm going to do the color in purple. So we're going to change this color, so it's going to be increasing from -infinity to -4, and then it's also going to be increasing one more time. So there's going to be two different portions where this function is going to be increasing. So it's going to be increasing from -infinity until -4, and we always enclose infinity or -infinity with a parentheses, and because we're describing an interval, we're going to enclose the -4 with a parentheses, and we recognize that it will also be joined with another interval, so we're going to represent that by a value of U. And then it's going to be increasing again from -1 until +2, and we're going to enclose these guys with a set of parentheses. I think most of you now can recognize there's going to be one last part. I'm going to circle it here. One last part. Let me circle it in green. So, no, let's not use green. Let us use gray. So when we look at this part right here, I'm going to circle it. This is a portion of my graph where the function is neither increasing nor decreasing, and it extends beyond a point. So in this circumstance, we're going to call this portion a constant portion of my function. So constant because the function is neither increasing nor decreasing, so it's going to be constant from a value of 2 and then extend out until 3, and we always enclose these with a set of parentheses. So when we examine the section that describes where functions are increasing and decreasing or constant, again, it is not always one unilateral definite area. Sometimes you have a function that is increasing, decreasing, and constant. Sometimes it could be increasing and decreasing. Sometimes it could be just decreasing. Some can be just constant. So describing them, you always use the domain values where the function is either increasing, decreasing, or constant, and you always enclose them with a set of parentheses.